Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 11 in our incredible new tutorial series where you are learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick a kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to do a little bit of a deep dive into the topic that we looked at last week in lesson number 10. Now, what we learned in lesson number 10 is we could simulate analog output voltages using the Arduino if we used one of those little squiggly pins, one of those digital pins with the squigglies. We can get something out of that that acts like an analog voltage. So what did we do? We showed that we could control the brightness of an LED with an analog write command. So if we did an analog write at a value of 255, it was full brightness. Of 127, it was half brightness, half again, quarter brightness, and we could control the brightness of the LED. And we did that by simulating analog voltages. Now, last week, I might have just said analog voltages and referred you to this week. So what we're going to learn this week is it's a little bit more complicated than that. Why? Well, what did we learn on those lessons, those earlier lessons about binary numbers? All digital computers only know what two things, on or off. Those correspond, if it's off, we call that a 0. If the switch is on, we call that a 1. So all digital computers know are 0s and 1s. Now on the Arduino, a 0 is 0 volts and a 1 is 5 volts. So in reality, the only thing that we can output to a digital pin with the Arduino is a what? A 0 or a 1. That corresponds to a voltage of 0 volts or 5 volts. So that then begs the question, if we can only output 0 volts or 5 volts, how are we getting all of those magnificent in between values in the last lesson where we could get all the different brightnesses between full bright and full off very smoothly? How did we do that? Well, we do it through the magic of pulse width modulation, which is oftentimes described as PWM. So that's what we're going to learn today. I'm going to take a sip of my coffee. I am going to get out of your way. We're going to come over to our Sketchpad view and we're going to look at this. Okay, so let's draw some pictures and see if we can understand pulse width modulation. So I think what I am going to do is I am going to draw a coordinate axis here. So I will start and I will draw my horizontal axis like that. And now I will draw my vertical axis like this. Okay, that looks pretty good. We'll come in and just for completeness, put some nice little arrows on this, like this and this. And what is our vertical axis? Our vertical axis is voltage, so we'll call this volts. And then our horizontal axis is time. Okay, so now let's do the easy ones. Let's say that we wanted to apply to the LED a full 5 volts. How would we do that? Well, the simplest thing would just be to do a digital write to that pin, comma, high. And high would be 5 volts. High would be on, right? It would be 5 volts. That would be the easiest way. Or we could do an analog write to that pin of the full value, which is what? 255. 255 is the number 2 raised to the 8th power minus 1 because we start counting at 0. And so 255 would be an 8-bit binary number, if that makes sense. Okay, so what do I want? I want 5 volts. So let's label this. We will call this 1 volt, 2 volts, 3 volts, and then this is 4 volts, and then this would be 5 volts. Okay, that looks pretty good. So what would I do if I wanted 5 volts? Well, I could either do a digital write high, or I could do an analog write with a value of 255. And what that would give me is, that would give me, let me try that again. Okay, that would give me, let me get my straight line here, and I think that'll look better. That would give me, here at this 5 volts, I would come like this. Boom. That would be 5 volts. Well, what if I wanted 0 volts? I could do a digital write low to the pin, or I could do an analog write with the right value of 0. And then that would come down here, and that would give me 0. Okay, so if I'm doing a 5 or a 0, that is really straightforward. But if I can only output a 5 or output a 0, what if I wanted 2.5 volts? What if I wanted halfway? I can only apply a 5 or a 0, but I want 2.5. How could I make something look like 2.5? Well, I could make a signal that averages to 2.5. How would I do that? I would turn the pin on to 5 volts for a certain period of time, and then I would turn it off to 0. So I would go 5, 0, 5, 0, 5, 0, and the time at 5 would be the same as the time at 0, and that would average. It would average to what? It would average to 2.5. Now that is what the Arduino does when you do the analog write command. Now I should be a little bit more specific here, and what I should say is one period, that total on time plus the total off time, is a fixed amount, and that is 2 milliseconds. Okay, now what we have to remember is let me put it this way. We just got to remember our units. 1 second is equal to 1,000 milliseconds. Okay. Now I could also tell you that 1 millisecond is equal to 1,000 microseconds. Okay. And so what I can see is that 1 millisecond is equal to 1/1000th of a second, okay? And then I could say 1 microsecond is equal to 1/1000th of a millisecond. And then what I could also say is 1 microsecond would therefore be what? 1/1,000,000th of a second. Okay, does that make sense? 1/1,000,000th of a second. So you just got to remember there's 1,000 milliseconds in a second, there's 1,000 microseconds in a milliseconds, and there's 1,000,000 microseconds in a second. So we got to do that because we're going to kind of start working with some of these units here. Well, what is that period? I said that the total on time plus the total off time is the period. And that period is always going to be the same when we're doing pulse width modulation. And that period is equal to 2 milliseconds. Okay, so I need to create a horizontal axis down here. And so what this is going to be, we're going to call this 0.5. Can you see that? Yeah, 0.5 milliseconds. And then this is 1 millisecond. And then this is 1.5 milliseconds. And then this is what? 2 milliseconds. Okay, so the whole period would come out here to 2 milliseconds. So if I want to do 5 volts, it stays on for 2 milliseconds, and then it stays on for 2 milliseconds, and then it stays on for 2 milliseconds. Okay, if I want a 0 volts, what does it do? It stays off for 2 milliseconds, and then off for 2 milliseconds, and then off for 2 milliseconds. What if I want 2.5 volts? Okay, what if I want 2.5 volts? That's 1, 2, 3, 4, 5. That looks a little bit not perfect, but what I want is I want 2.5 volts. And so that would be halfway between 2 and 3. And so what I want here is 2.5 volts. Now, what I cannot do is I can't stay on 2.5 volts for 2 milliseconds. Why? I can only be a 5 volt or a 0. Well, how could I get this halfway value? The way that I could get this halfway value would be to stay on at 5 volts for 1 millisecond, and then turn off, and then I could stay off for 1 millisecond. Does that make sense? So I'm on half the time, I'm off half the time, so that starts looking like what? 2.5 volts. Well, what if I wanted 1 volt? If I wanted 1 volt, I would stay on 20% of the time. Okay, this would be 1, 2, 3, 4. I would stay on for 1 volt. I would stay on for 20% of the time. And so it would look something like this. I would come over, and then I would come down, and then I would come over, and I am staying on for 20% of the time. And so that would start looking a lot like what? 1 volt. Okay, so what you're doing is you're not creating a 1 volt signal, you're creating a signal that averages to 1 volt in time, or you're creating a signal that averages to 2.5 volts over time. Now, what are we writing? We're writing values of, okay, we're writing values that are between 0 and 255. So what? Let me try this here. We're writing values between 0 and 255. Well, these are all going to be between 0 and 5 volts. But what if I did, let's say, 126, right? 126 would be 1/2 on and 1/2 off. Okay, what if I did 62? 62 would be about 1/4 of the time on, and it would be 3/4 of the time off. Okay, what if I did 25? That's 10% of 255. That would be 10% of 5 volts would be like 0.5 volts. That would be 1/2 of a volt. That would be 1/10 of the time on, and that would be 9/10 of the time off. Okay, so what we're doing is we're just turning it on and off at a rate that allows us to average out to the value that we want. But in the end, we are only applying a 0 volts or a 5 volts. Okay, hopefully that makes sense. And I've kind of tried to draw it out here for you, but let's go in and let's see if we can play around with this a little bit. And what I have set up for you to kind of understand it more practically in the real world here, what you can see is that here is our trusty Arduino Uno R4 Wi-Fi. And then I have that pin 11. Yeah, it's that pin 11 that we were using last week. I have it hooked up to the oscilloscope probe here, to the oscilloscope probe. You see that? And then I have the ground wire hooked to the ground of the oscilloscope, and then I have that going into channel 1 of the oscilloscope. And what does the oscilloscope do? It shows you a picture of the voltage form. Just like over here, I kind of drew you a picture. What the oscilloscope does is it actually takes a snapshot of that voltage that you're applying, and it makes a graph of it, and then we can kind of look at it and figure out what is going on. Okay, well, if we're going to do that, we need to set up a program. So let's just come over here, and I think I might just go to this view this time, and let's write that program real quick that would apply an analog signal, a simulated analog signal, a pulse width modulation signal over to that most excellent pin 12. Was it pin 12? No, it wasn't pin 12. It was pin 11. Okay, so what do? I'll say PWM pin. What pin was that? It was going to be pin 11. Okay, and then I need a bright value, and I'm going to set that bright value. I'm going to set it halfway to begin with. So half of 255 would be about 126, let's say. And then I'm going to come down here. If I'm going to use that pin 11, what do I need to do? A pin mode of pin 11. No, not pin 11. What? PWM pin, like that. And then what is it going to be? It is going to be an output like that. Okay. And remember, you've got to use a squiggly. If you want the PWM, you've got to use a squiggly. Okay, now when I come down here, what do I want to do? I want to do an analog write. Analog write. And what do I want to write? I want to write to PWM pin, and then what do I want to write? I want to write that brightness value. Okay, and so we're trying to simulate 2.5 volts. We only have a 5 volt signal, so what are we going to want to do? We are going to want to turn on and off that 5 volt signal where it's on half the time and off half the time. Okay, so now I think I'm going to come over here to this view, and now what you're seeing, hopefully, if this thing can focus in, that sort of really lost its focus. Let's see if we can get that to focus. Okay, yeah, that looks like it's focused in a little bit better now. So you can see right now there is just 0 volts. Nothing's being applied. But now what we're going to do over here is we're going to run this program, and then we're going to see if we can see. We're going to see if we can see. Why does that not want to focus? Okay, hopefully that'll hold the focus. Now what we're going to do is we're going to see if we can see the voltage when we're trying to simulate 2.5 volts, which would be a bright value of 126. So we're going to run this thing, and it is compiling. Did PWM pin, what did I do? PWM pin, that looks good. PWM pin, that looks good. Why did it not like that? I forgot. Did you guys catch that? I got to declare it. It's an int. It's an int. Did that make sense? Okay, let's try running it again. And this time, hopefully, we won't see any of those ugly little orange messages. Okay, it is compiled. It is downloading. And boom, look at that. Okay, look at that. Let me adjust this a little bit. Okay, let me adjust this a little bit. Give me just a second here. Okay, look at that. Okay, so what I want you to do is I want you to look right here. We're going to call this time 0. Okay, we're going to call this time 0, and then we pop up to this voltage, and we stay for 2. We stay for 2 divisions, and we go down, and we stay for 2 divisions. So up 2 divisions, down 2 divisions. We're on for how long? Half the time. So that 5 volt signal averages out to what? It averages out to 2.5 volts. Now, a couple of interesting things here is this down here says each division for this signal is 500 microseconds. So we are on for 500 microseconds. Another 500 microseconds would be 1,000 microseconds. 1,000 microseconds is 1 millisecond. So we are on for 1 millisecond. Then we turn off and we stay off for 500 microseconds. 500 microseconds makes 1,000 microseconds. 1,000 microseconds is 1 millisecond. So we go on for a millisecond. We go off for a millisecond. Then what do? We repeat. So we're going on and off like 1,000 times a second. Okay, we're going on and off 1,000 times a second. And that's so fast you're not even going to see it, but it does create this simulated analog value. Now let's try something else. Let's say that we wanted 1/10 of a volt. Well, if we wanted 1/10 of a volt, we would need, if we wanted 1/10 of a volt, that, or no, I don't want to do 1/10 of a volt. Let's do 0.5 volts. 0.5 volts would be 10% of 5. That would be 10% of 255. That would be what? About 26. So we're going to make that 26. And now what do we expect? We expect it to be up for 10% of the time and down for 90% of the time. While it's downloading, it's shut off, and boom, look at that. So now let's see, for one cycle I've got 1, 2, 3, 4, and it looks like I am a little less than a half of a fourth, and a half times a fourth would be an eighth. I'm a little less than that. So you can see indeed about 10% of that cycle I'm on and 90% of the cycle I'm off. That is going to simulate a 0.5 volt signal. What if we went really, really low? What if we went for 1 out of 255 on the brightness? And let's do that and see what happens. And boom, you see it's just barely on. It's barely on because it's 1 part out of 255. So that's less than 1%. And so that would be like something like 0.05 volts there. That would be a very, very small voltage because it's off most of the time. Well, what if we said, let's see, what would 90%, 0.9, I'll use a calculator here. I'll say 0.9 times 255 would be like 230. And so 230 would be 0.9 times 5. This would be like 4.5 volts if I put that at 230. And we're going to run it. And then what are we going to see? Boom. You see it is on for most of the time and then off and back on. Now what I want you to see is no matter how I'm changing that right voltage, notice that it is always 1, 2, 3, 4. 4 times 500 microseconds is 2,000 microseconds, which is 2 milliseconds. So from one cycle, no matter what PWM value you write, no matter what analog write value you write, you always have one period of 2 milliseconds. It's just how much of that period are you on and how much of that period are you off. So we have learned something pretty cool today. Guys, if you want to play around with one of these oscilloscopes, you don't have to have it for this class. You don't need it for the class, but I did put a link down below in Amazon in case you guys want to play around with an oscilloscope and be able to look at your signals. I guess the other thing that I could say here is, man, this thing is really not wanting to focus. Do you see how it said 500 microseconds per division? So we go 500, 1,000, 1,500, 2,000 microseconds. Each division this way is worth 500 microseconds. Well, how about in the vertical? In the vertical, each division is worth 2 volts. I have 2 volts per division. And so I go 1, 2, no, I'm sorry. It says 1 volt per division, 1 volt per division. So I start at 0 volts, 1 volt, 2 volt, 3 volt, 4 volt. And this line would be 5 volts. So you can see out of my Arduino, I'm not actually getting a full 5 volts. I am getting like 4.8 volts. Well, a lot of times that's because your USB cable is probably coming in right at 5 volts, but that USB cable might be a little bit low on the voltage it's supplying. And also a lot of times you'll have some protection diodes in there and you'll get like a few tenths of a volt drop across those diodes. And so you see, I am not really getting exactly 5 volts. Looks like I am getting more like 4.8 or maybe 4.75 volts out of it. Okay, guys, so what did we learn today? We learned that digital devices, computers, only know what? Zeros and ones. For the Arduino, that corresponds to 0 volts and 5 volts. And how do we get the in-between values? We trick it by switching on and off, but it doesn't know 2.5 volts. It knows 0 volts or it knows 5 volts. And that is how it works. So when we give an analog write command, right, the command down here is called analog write. We are not really analog writing. We are what? What is that doing that? That is giving me trouble. We are not really... Get out of there. Okay. This is just really getting kind of annoying. We are not really analog writing. What are we doing? We're PWM writing. And so you've got to understand you're not really putting an analog value out. You're just simulating one. Okay, guys, I hope you are having as much fun taking these classes as I am making them. I guess I really don't have a homework assignment for you. I guess what your homework assignment would be, leave a comment down below and sort of summarize what you learned in this class. Say it in your own words so that I can see that you really understand what I'm saying, because this is a really important concept. So you can kind of summarize in a comment down below what you've learned in this lesson, and that will be your homework for this time. Next week, what we're going to do is, we've learned so far how to do digital writes. We've learned how to do analog writes, which are simulated PWM writes. And now next week, what we're going to do is we're going to learn how to start reading from the pins. Instead of just talking to them, we're going to start reading from them. We're going to start reading voltage values back from those pins. Okay, so that'll be something a little bit new, and that is what we're going to do next week. Okay, guys, want to thank you all. Especially always want to give a shout out to you guys who are helping me out over at Patreon. You guys that are supporting me on Patreon, you're keeping this great content coming. You're the ones that are keeping me in the game. Good job. Thank you. You guys can also help me out with the thumbs up. It also helps with the old YouTube juice if you'll leave a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so that you'll get notifications when future lessons drop. And most importantly, share this with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.